everyone and welcome back to this video. In this video we're going to be looking at real numbers chapter 1 of class 10 maths, and this is the second part. So let's begin. Now, important points about irrational numbers and rational numbers. If x and y are two distinct positive rational numbers, then x plus y over 2 is a rational number between them. That is the average. Now, if x and y are two distinct positive irrational numbers, then under root xy is the irrational number between them. Alright, if you add or subtract an irrational number to any irrational number, the answer may be irrational or rational. Because if you've got root 2 and you add root 2 to it, you'd get a different number. You'd get 2 root 2, right? I think. But if you've got a number like root 2 minus root 2, now that's going to give you 0. So that makes a rational number, but this makes an irrational number. Okay, so that's pretty much it. Also, if you've got like root 3 times root 2, you'd get root 6, I think. Alright, never mind that. Let's move on. If you multiply or divide an irrational number by any irrational number, then the number may be rational or irrational. Over here you can see root 2 times root 3 is root 6, but root 2 times 2 root 2 is 4. So here we got a irrational number, and here we got a rational number, right? So it can be different. Now, if you multiply a rational number by another rational number, then the answer will always be rational. If you divide a rational number by any non-zero rational number, then the answer will always be rational. So if you've got, this is basically p by q is always rational, because this is not equal to 0, so that works. But if it is 0, as we discussed, it would be undefined. So the sum of a rational number and an irrational number is irrational. So if you add 0 plus root 2, that gives us root 2. So that is irrational. Alright. So now let's move on. Important, if p divides a square, then p divides a. Very important. So if you've got 10 square, 100 is equal to 2 times 5 times 2 times 5, right? But if let's say 10 divides, 5 divides, and 2 divides, or 4 divides, or 25 divides, all those numbers divide 100. Then p divides a. So this is a square. Then 10 is equal to 2 times 5. So we can say 10 divides it. We can say 5 divides it, 2 divides it. Yeah, it divides lots of numbers. So this is what we're trying to say. If p is a prime number and a is a composite number, very important. We're not talking about any other numbers other than prime numbers, only prime numbers. See, the problem before was that we had 2 times 5 times 2 times 5, and we can divide it by 25, we can divide it by 4, but we cannot divide 10 by 25 or 4. So we can see that 10 is equal to just 2 times 5. We can see that 100 is going to be the same thing times itself. So we're always going to have the same factors. So either way, 2 will divide 100 and 10, and 5 will divide 100 and 10. So that's what we're talking about. Now, this is Sorry, this one was meant to be multiplication, by the way, guys. That's a little bit of a problem. But yeah, let's move on. Prove that root 2 is irrational. That we can do by using a contradiction method. Now, first we have to assume that root 2 is rational. So root 2 can be written in the form of p by q, and root 2 can be written in the form of m by n. M and n are co-primes. Now, what are coprimes? Coprimes are numbers which only have a common factor of 1. So the most simplified fraction, like 2 by 3, here we can see that 2 and 3 are coprimes because you cannot divide them by any other number. So, if we do a little bit of shifting, we get that root 2n is equal to m. Now we get that 2n square. If we square both sides, then that is equal to m square. So 2 divides n square and m, right? So we can see that 2 divides m square and m. So m is equal to 2b, meaning if 2 can divide m square and m, then something times 2 must be equal to m, right? So that b is that little something that we multiplied by. So m square is equal to 4b square and root 2n square. Now if we go back to here, 2n square is equal to m square, so we see that 4b square. Now we can see 2n square is equal to 4b square. If we divide it by 2, then we get n square is equal to 2b square. So 2 divides n square and n, as we can see, because it is a factor over here. If this was n, it would work as well because we just learned about it. So this means that n and m aren't coprimes, which proves our assumption to be wrong. Root 2 is irrational. Alright? Now the last one is the decimal expansion of rational numbers. So decimal expansion is basically, it can be terminating, it can be non-terminating. But if it is non-terminating and it's repeating, oh my god, if it's repeating, then that means that it is a rational number. But if it's non-repeating, then it is a rational number. Alright, rational numbers written in terminating and non-terminating but repeating. Now, terminating, if you write it in the form of p by q, then q is in the form of 2 to the power of n times 5 to the power of m. So that's going to be our prime factorization. Now, if you've got 2 by 10 over here, this is equal to 2 by 2 to the power of 1 times 5 to the power of 1. So we can see that it is going to be terminating according to what we learned, right? So, and it is going to be terminating because 1 by 5 is, if we divide 1 by 5, we go 0 minus 0, 1, 2 point. We add a point, we get that, we get 2. So that's going to be 0.2. So it is terminating. But if it's non-terminating but repeating, then the q is not going to be in the form of this. Alright? So now one common question is write 234.567, which has a bar on top, meaning it's repeating, in the form of p by q. Now we know that it is rational, so we can write it in the form of p by q because it's repeating, right? So now let's say 234.567 over is equal to x. So 234,567.567 is equal to 1000x, right? So now if we subtract this one from this one, then we'd get 234,333.000. I just did that there, right? Is equal to 999x. Now from here, we can get this 9 down here, so it would become 234,333.999 is equal to x. So our answer would be that. Alright, with that, we're finished the revision of this chapter. Hope you enjoyed, hope you learned something new, and I'll see you in the next video. Till then, take care and bye bye.